In this video, we are going to talk about the 12 basic or parent functions, we call them. So in your notes, it'd be good to get out some graph paper and draw a nice simple sketch of each one of these 12 basic functions. So our first graph is just going to be a sketch of what we call a constant function. That's when y equals a constant k. So like y equals 2, y equals 3, something like that. So just draw a nice straight horizontal line to represent the constant function y equals k. The second one we're going to draw is a linear function. So the parent function for linear is just y equals x. So it is that really basic line that goes right through the origin and has a slope of 1, just right through the middle of the graph. That's our basic parent linear function. The next one we're going to write down is quadratic. The basic function for quadratic is just y equals x squared. So we start at 0, 0, and then we can go 1, 1, because 1 squared equals 1, 2 squared equals 4, and then there would be 1 on the opposite side. So it helps us to have a nice sketch of our graph if we have a couple of points. So we get a little sketch of quadratic. Then let's graph our cubic function. So the parent function for cubic is y equals x cubed. So 0 cubed is equal to 0. 1 cubed is equal to 1. 2 cubed is equal to 8. So 1, 2, 3, 4, 5, 6, 7, it'd be about right there. And then the same thing would happen, but in this third quadrant. So you can use your calculator to help get a little picture of it, or just make a nice, decent sketch of what cubic would look like. It's just good to be able to kind of recognize when something is cubic. And then your basic parent function is y equals x cubed. So those are the first 4. Let's continue. So after quadratic, we're going to put, or after cubic, we need to put the square root function, which is just y equals the square root of x. So if we just start at 0 and kind of go up from there, it's not going to have any negatives because we can't have a negative value for x right there, just like we have always talked about with square roots. The cube root function is just simply y equals the cube root of x. So this one can have negative values for x, so it kind of looks like a sideways version of cubic. So here's cubic. Think of it as turning it sideways, because this is the inverse function for cubic. And square root kind of looks like a sideways quadratic function. It just can't have those negative values for x. So that's why it looks a little different. Then moving on, let's put, the next one is reciprocal. So y equals 1 over x. This will be what we work on with our rational unit later on. So for this one, we have these little branches, we call them. They kind of hug the x-axis but don't cross over it. And then it'll hug the y-axis but not cross over it. And then the same thing here. This is just your basic graph of a reciprocal function. So we call these little pieces of our graph branches. It might be good to go ahead and add that to your notes. The next one we're going to write down is absolute value. So we just write y equals the absolute value of x, just that basic parent function. So in the middle, we put it out at 0, 0, and then it's like going 1 as our slope in that direction. Looks like a V. So going up 1 box over 1 box in each direction makes a nice normal looking V, and that's just our basic parent function for absolute value. The next one's going to be logarithmic. We say log for short. And our parent function is y equals log base b. So it's a little superscript b right there. Subscript b. And then x. So log base b of x. So maybe write that out. We say that as log base b of x is how you say that. A lot of people have trouble with that. And then it's going to come kind of from negative infinity up and level off. But that's just kind of what the basic function looks like. Again, that's all we're worried about right now. The next one's going to be exponential. So we put y equals b to the x power. So it's a base of b with an x for your exponent. And it comes from that negative direction, kind of hugs the x-axis right there, and then jumps up. Okay, we have two more very unique graphs. These are going to be our two basic trig functions later on, but we're going to go ahead and add them to our notes because they are part of our 12 basic functions. So our first one is sine. Y equals sine of x. So take a minute to actually sketch this one with a few details involved. So if we have a y-axis that goes from 1 to negative 1, the sine function is going to start at 0, and at pi over 2, put a little dot right there at 1. And then at pi, and you can just make these kind of equally spaced out and just label them for now like this, and we will certainly talk more about that when we get to trig. Put a dot at 0 for pi, at negative 1 for 3 pi divided by 2, and then back to 2 pi. And then draw kind of an S curve that is sideways. And that's your basic sine function, your parent sine function. And our last one is similar to that in the way it's set up, but different otherwise. Y equals the cosine of x. So this one's going to start at 1, so put a 1 and a negative 1 again. So sine started at 0, cosine is going to start at 1, and then go down to pi over 2. Then at pi, it's going to go down to 1. Make sure you can see that. And then it's going to come back up to 0 for 3 pi over 2, and back all the way up to positive 1. So it'll end up looking kind of like a U-shaped graph. So that's pretty decent. So take a minute and draw all 12 of these functions nice and neat in your notes, and hopefully you have a little bit of graph paper to make that look a little nicer. So the next video we do, we're going to talk about transformations of these functions.